Alright, and we are now live. Hello everyone, and welcome to today's Blender live stream, where I finally got the face rolling working as intended. This was very difficult to figure out, simply because one of the topology nodes that I thought would act one way acted another way. But once I figured that out, I was able to make this work as intended. So essentially this takes a ton of faces and makes them roll. So here I can do with this object. We just do this little slider. It's a little bit slow, but it just rolls. That's the one thing that I do want to change. I want to make it a lot more efficient with all that. Oh, it even works with non-quad meshes. Or faces in this case. I'm surprised. I thought it would freak out. Well, that's good to know. But yeah, I'll basically roll and unroll. This one is going to be super laggy. But let's just put in a geometry node here. Do the face rolling version 3. We need to assign a start face. So in this case, it'll just be group, and I forgot to put the vertex group as a named attribute in the part right here, but that's fine for now. I could fix that, but I'll just leave it as group. So here, if we unroll it, oh, that is so incredibly laggy. Oh, that is painful. But yeah, it works, even though it is extremely slow. Wow. Okay, that's the checker version. Let me go and decimate. So I'll just keep the mesh here. But I'm going to go and just decimate this one. Yeah. That's a bit better. Let's just do that. I could also unsubdivide it. Yeah, let's go down to subdivision level, do that. So this should be twice as fast. There we go. So now... Oh, wait. Need to assign the vertex thing. There we go. So now if we do this, still slow. That's unfortunate. Let's go and do another decimate on top of it. That good? Yeah, that's good enough for my standards. Let's do it again. There we go. Oh. Oh no. Is that just because there still are some bugs to it, which I need to figure out? As we can see, some of these are being left behind, which is really bad. I think that's because with tri-meshes, it's still a little bit funky. While with quad meshes, it's just a breeze. It's just, oh, we're just doing that. Which is very odd, because the parts that I'm basing this on are... There was a tutorial by Intagma quite a while ago that did something along these lines, except it was in Houdini with scripting and all that, which, as you can probably guess, I'm not the biggest fan of scripting because Geometry Nodes doesn't support it. Uh-oh, is the stream okay? Uh-oh, are we live? Just going to assume that we are. Oops. Yeah, it should be good, just my preview is super bugged out at the moment. But yeah, I needed to convert this into nodes, which was very difficult. So let me go over how this works very basically. So first we have, yeah, I can use the elusive viewer node. We have a gradient, which, let me just put this in here. It's a little hard to see, so let me use the divide node to show this. We have a gradient going from the back to the front using the shortest edge paths node. We store that as a gradient that goes up by 1, or in this case 2, every single iteration. I have it set to 2 because that makes it work on triangles, which I wonder if that, yeah. I keep increasing it. Oh, the more I increase this, the fewer bugs we get. That's very odd. That means that there is a bug with the gradient storing, which I will need to figure out. I'm also thinking that I might need to make my own shortest edge paths node, because this is on the vertex domain, while maybe I should have it on the face domain. I'll need to see about that. But after that, here's the difficult part. We need to find its parent face. So each face needs to find its parent face according to the gradient, which that was extremely difficult. I needed to create my own node for that, and this is what it looks like. It is painful. It is difficult. It is... I need to find a better method, because I think this one is still bugged out, as we can see with the one over here. Faces get left behind if they are not quads. Even though there are versions of this over here where they are, where they are triangles, and they do work. But just, I guess at some angles it just doesn't want to function as intended. But yeah. So we find the face parents, and then we get, yeah, we get the face. This is a little difficult to explain. We get the face parent corner, so let me try to explain this as best I can. So this face is looking at this face corner as its parent. And then it also gets this face corner, just the two that are right across from each other. Oh, and that might explain why that's a little bit messed up. No, it's still messed up even if I do that. Okay, so I'll need to figure that out. So each face gets a parent face corner 1 and face corner 2. Essentially an edge, because with the face splitting, the edges get rearranged, so I have to go with face corners. So then I split the edges, and then I store the current location of the parent and the rotation of the parent's face. So I store the rotation of the face and also the location, which would be right here. And then I basically do matrix math, I assume, where I undo the location to its parent's face, do a rotation value and a scale, and then redo the transforms of the parent. So... yeah, this is difficult. Oh no, it's buffering again. But that's the node setup. Don't worry about the gradient here, like this mostly is just me getting the normalized, like, factor. So if I just go and literally just delete this, it's just, ooh, there it goes. So don't worry about that section. That's just difficult. I just need to get the max iterations for the repeat zone, so that it does one face at a time sequentially according to the gradients. And yeah, I don't recommend copying this. Don't attempt it. It has taken me over 10 hours to figure this out. I've been working on this on and off for literally months. Like every once in a while I would come back and say, oh, can I do it now? Can I do it now? Can I do it now? Which the problem wasn't necessarily me, it's that we don't have good nodes for this. So for one face to find its parent's face, according to gradients, it's difficult, because we have to compare the gradient values. To find its parent's face, there we go. It basically looks at the current face setup. Hello, where be wireframe? There we go. Each face has to compare each face around it and say, oh, which one has the lowest value? And then it says, oh, that's my parent face. Use the dual mesh node to find the neighboring faces. If that works, I will be... Would that work? I'll need to look at that because I'm not sure. Because we need to paste the neighbor ID onto this original face. So if I use the dual mesh node, it might not work as intended. It does, I've tried. I'll have to look into that. Edges of vertices. I did try the edges of vertices node. That's what I'm currently using. But it is difficult to figure out because first the edges of vertices node doesn't exactly work as you would think it would, because there's no, it doesn't sort by default. You have to implement that yourself. But you also have to check if the edge vertex is on the inside or the outside, because it doesn't give you that information. So I have to do a check if the corner of the edge is on the original face or the outside face, so that only picks the outside face one. A lot of really annoying math. But I'll look into the dual mesh node, because I think that might be my savior in this case. Yeah, I should have thought of that. I guess I was thinking, okay, don't change the topology whatsoever. But yeah, the dual mesh node, I'll need to keep boundaries. So that basically gives me that version. So I need to see... Oh, that probably... I think that would work. Yeah. Okay. I just need to make sure that the indices don't go wacko mode. But I'll figure that out off stream. I have a version that works for the most part, and I'll figure that out. But thank you very much for pointing me in that direction. That is very good. So yeah, that it works. So I'm well, for the most part. Maybe the dual mesh will help with in that regard as well. But yes, I am very happy to have this finally mostly done. Mostly. So I want to go and separate the arm of this object and apply it to the arm. So let's just remove that. Go to 1, There we go. Let's go and apply the geometry node. Face rolling. I do like how in the new menu, geometry nodes is just its own thing. Because, I don't know, it's just so much more convenient. But all of these are a lot less convenient to go and look inside of. Which is, The Blender devs were talking in the Blender conference about why they did that. And I still need to figure out, like, the ins and outs of that. But there we go. Okay. So if the dual mesh does work, if I can get it working, it'll probably be much more efficient than the current method that I'm trying out. But yeah, this is what I want to do. Like, here, let's set this to be like 30. No, let's set it to be 50. And this isn't 50 faces because there's a little problem with it. But if you want to spaghettify your model, that's how you would do it. Spaghetti. So I could also make this the complete edge ring, and that might work as intended. So here, if we do that, just It does look like one gets left behind, but again, I'm going to assume that the dual mesh node will fix all those problems for me. So that's good to see. So yeah, that's that. And I want to showcase another thing that I've been working on. This will be a shorter stream just because I'm showcasing what I'm doing, my research and development. I've spent so long on this that I need to figure out the rest of it. It's cool. So let me just switch over to the other file and save this current one. There we go. So now this one, let me just go and get it ready. This one I'm very excited about because it is shape keys. So right now I have the model, the character face model from Charge. You might see that the character has an expression. But as we can see, I can slide it using geometry nodes, which this is essentially shape keys. I got the shape key node that they had from Wing It, the other Blender open movie. And then I went through and I was like, here, let me showcase this in detail. Ignore my very interesting deformed tests here. I was just like, oh, just move it down. So here's the one that the Blender devs had. As we can see that there are errors wherever the UV seams are, and it just doesn't work quite that well. And if we look at the timing, it is slow. It is 20 milliseconds for just that model. And if we look through here, it's a little, not to rag on it too much, but it's a little all over the place. If we look inside the UV space tangent node, again, a little all over the place. So I was like, how much can I optimize this? So I went and did some work behind the scenes, and turns out I could optimize it severely. With this one, it is 6.2 milliseconds versus the 20 milliseconds it was before, so that's over 3 times in savings, which is very nice. And then also, I found another algorithm for the UV tangent node. I had to merge the algorithm that I found and the Blender Dev version together in order to get this one. So this is how you get UV tangents. I'll just go and leave this up in case you ever need it, because this was another thing that was extremely annoying to figure out. So just go and absorb this for a little bit if you want to copy it. So there's that. So that's a much more efficient UV tangent node. This one does not... Oh, I don't need you in there. Looks like I left some nodes in there. With the Blender Dev's original UV tangent space node, this one is very, very weird because they split the UV seams, even though that's not necessary because they're using the face corner domain. Then they do a lot of math, which in this case I won't explain it right now, but this setup does not work when you try rotating the UV map. It's a little weird. Maybe I can showcase it. Here, let me... So, when I was making my version, I was constantly comparing it to... Let's see... the shader UV tangents. So if we look at this, I think I'll be able to show what's going on. So let me just store named attribute on the base corner, vector base corner. I'll label it T for tangents, because that was what I was viewing. Let's take a look at this. Should be showing right now. Intriguing. Why is it? Oh, that's why. Another downside of this method is that you need to have it connected in the actual geometry stream, which is another weird caveat. A weird thing that I was like, that probably could just be a reference. Hello? Oh, interesting. Oh, yeah, lots of weird things with this setup, which is why I was like, I need to heavily optimize it. So let me store the T-named attribute on the actual geometry that is being manipulated. Again, there was a lot of very weird things done with this that I felt like needed some fixing up. So with this one, we can see that the difference between the two is extremely little. Let me set this to flat shading. It's not too much, but you can realize there are quite a few errors. While with my version over here, let me store the tangents on a named attribute once again. And put this into here. Shade flat. Is this on the moved one, or... Ah, okay, that was on the moved one. Okay, let's just move it just a little bit so that it enables. There we go. So here we can see the error difference between the two. This one has a lot of weird things going on right there. I need to make sure I'm giving an accurate comparison. But the issue with this one was if the UV maps are not parallel, if they're rotated like these ones are, it would give an inaccurate result, as we can see with the error things right there. But with this one, with the other algorithm that I found online from another Blender user, but with that one, I'm forgetting their name, I apologize for that. But I took their algorithm and that they found online. They found a code snippet, converted it into nodes, and I took the original code snippet, redid it, optimized it, and then implemented it So this is like theirs, except different because I referenced the code that they referenced. It was very annoying to figure out, but I got it working. I optimized it, so that's a lot less nodes and so on. But basically, the error between the actual shader tangent and this one is extremely small. It can't be 0, because with Blender, the tangent is triangulated whenever it's put into the shader. Well, this one is getting the tangent of the quads. So if I were to triangulate this mesh, we'll see that it gets even lower than before. Still a little bit off, but very, very close. It can't be exact, but it's as close as I can make it. So with all that out of the way, basically, with this one, it's a lot lighter than the one that was in Wing It. Hopefully that was somewhat understandable. But yeah. Yep. So... yeah, I think that's everything about that. But it just has one stream of data going to there. So let me show how this works. After I did the very technical overview, let me show how it actually functions. So here, with regular shape keys in Blender, you need to have a basis and then your actual deformed mesh, which is normally fine, but what if your deformation is on another mesh? You usually need to copy that. Or what if you want to sculpt on the other mesh and not have to worry about, oh, am I sculpting over the basis? So what I did over here is I made it so that you can have your default position and then reference a deformed position. So in this case, let me go and just set it here again. We'll have a deformed mesh. This one is a little bit twisted. So it's like, oh, I need to reference the original mesh and then the offset mesh. So let me go and add that in. Geometry nodes right here. We'll go and make sure that the UV map is set. I need to find a version that's not reliant on the UV map, but I haven't figured that out just yet. We go and reference the rest object, and then the deformed object. In this case, I'll choose the happy face. We can see here that no matter how deformed this mesh is, the offsets are accurate. Happy, smiley. And then we can just swap out whatever shape we want with an actual mesh. So here, we'll go sad, we'll go stern, and so on. Maybe I should make it so that if there's none, actually, if there's no object, having the object disappear will tell you, hey, there's an error. So I think that might be better. So there we go. So I could go and just warp this mesh in real time while not having to worry about if I'm affecting the basis at all. So this is might be a better way of working. So I could just go and give this guy a very long chin or just a long face in general, or smush his face, you know, do all the funny things like that. As we can see, it is working as intended. The reason you might be like, oh, why are you mixing with all this math instead of just mixing the positions? Well, that's because this needs to be in UV tangent space, in local space, so that if it does deform, like if I were to simple deform this object, if I were to deform it, a regular position transfer would not function correctly. As we can, let's see over here, let me go back to the happy face. If I do this, then it actually deforms properly, even though the mesh, if this were, say, an armature, it would deform well. So long story short, I basically remade shape keys and geometry nodes, and I'm looking forward to what I can do next with it. The one thing that I could do, with a little bit of modifications, is I can make it so that the shape key is based on location, rather than just a slider like this one is. So let me go over to the factor over here, and I can make it so that a noise texture affects it. So let me use an add node and then a clamp, plug this into here, make sure that there is a position input. Now I can make it so that if I find out the noise texture, maybe I'll use a map range so that we can see a very harsh cutoff with all this. 0.25, or no, let's make this 0.5. There we go. Let's try and make this as extreme as possible just to showcase it. So here, do-do-do. The offset is being done via a noise texture instead of it just being one value, which could be good if you're, say, doing like maybe a Hulk transformation or a shapeshifter animation. I want to try a shapeshifter animation, because that would be cool. Let me go and reopen the file real quick, just to kind of reset it. There we go. But yeah, I'm happy with this. So this stream was just to showcase two fairly annoying projects that I've been trying to do for a couple months. And now I finally have gotten working versions of both. So let's just make this guy extremely happy. Like very, very distorted happy. Just to show it in a very, again, extreme light. And I could just go and keep copying these. So it's like, oh, I want this guy to have a larger face. I can just keep doing that. I don't know, I find it helpful to have every different sculpt as a different object. And then you can just go and store it like this. You can just go and reference it. And you can also stack these. As you can see, it goes a little bit funky when you do that. But in this case, if you want to stack happy and sad, you can do that. So here, the person is happy and sad. So either or you can do. I'm not sure if those are errors or just the mesh freaking out because it's being so deformed, but I'll have to look into that. So yeah, shape keys. It could be, I can deform this original object, any orientation. All it needs is the same UV map and vertex indices. Let me go over to here. Why is that on? But yeah, I can deform the face in many horrific ways, and it will function completely as intended. So I'll just go and turn this guy into spaghetti. And it still works, even though it really doesn't look like it. But yeah, the guy is happy about it. Alright, if you have any questions about this, please ask them now, because I think I will wrap up the stream in this case. Just want to showcase these two. Because it's, this was difficult to figure out. The face rolling was much more difficult than the shape keys, but both were fairly annoying. Just getting UV tangents were annoying because I was like, oh, like those of you who have watched many of these streams know that I've been trying to find out a good way of getting the UV tangent for a while. The previous version would be to use the UV sample node, sample UV surface node, take the current UV map, and then, wait, let's get the named attribute just to show the old method. It would just be this, and then add the tiniest amounts to this to get the position from there. Then you would compare that position to its own previous position, normalize and all that, and that would be your UV tangent. The problem was that this method was extremely slow. And the other problem was, it wouldn't work at the UV seams. While this new version is on the face corner domain. So with seams, it's just like, oh, no problem. The only real downside with this is that it doesn't give a super accurate smoothened tangent. Like, you can evaluate it on the point domain, but then it starts to kind of freak out again, which is a little odd. It freaks out only at the seams again, which if we go and look at this tangent here, it looks smooth. That's because it's on the point domain, or it interpolates by the point, until it gets to the actual UV seam, which is interesting. As far as I know, with the one that the Blender devs made, it is not on the... Oh, I'm talking away from the mic. My apologies. With the ones the Blender devs made, I'm pretty sure that it's not on the point domain. Or it's not a smoothened version of it. Yeah, no, this one's just face dependent. Which, oddly enough, once you go and set the offset, it is now in the point domain. Which I assume is why with the Blender dev version, it really dislikes the UV seams. Like this right here, it just bugs out. Which in the original... Whoa, what the heck? Oh, yeah. No wonder it's freaking out. It's, yeah, this has a higher poly count. Yeah, no wonder. But yeah, if these have different mesh indices, we can see it messes up a bit, just because it's being mismatched. But if you want to, say, subdivide it after the fact, it'll be fine. So yeah. I'm thinking about putting this up on Gumroad for free, because I know many people have been trying to, well, several people have been trying to do this, and it's very annoying. Like, it's so difficult that even the ones that the Blender devs created was very difficult and still had some bugs, which my version still has. I think the main bug is the smoothing interpolation. That one is still a bit off. But for now, it's alright. The one piece of data, though, that I do kind of want, well, with, again, let me just explain this in extreme detail, because that's what I do. With these ones, this is not, it's only referencing the sculpt object. It's not referencing a base object, which you might be wondering, why? Well, this is because they stored a rest position attribute in here, which I actually canned that data, which is not great. But they assign a named attribute before any of the armature deformations, so that it gets the default position. Well, with mine, it references the base. So I just have an object existing that's in its default pose. So does that make it more expensive? It might. I'm not entirely sure. Instead of it referencing its data, it just references this object's data. It's probably a little bit more expensive computational-wise, but it's probably not that bad. But yeah, here we just reference the rest position, and we compare that using the UV tangent space to get the local offset to the moved position. And then we sample that, put into the main object, data flow right here, then apply the global offsets. We convert the local offsets to global offsets, and then we apply them. Oh, maybe I should try using this method for the face rolling. No. This isn't, yeah, no, no. I think my current version is good enough. Maybe I'll try it. Because with these parts were taken from the dev file, so I'm not entirely clear on how specifically they work. I just know that they do. But I'll test that. Alright, we're at 30 minutes right now. I think I explained everything in excruciating detail. So I'll just leave that as is. I'll just leave you with the happy guy. Very cartoonishly happy. But yeah, if you're interested in this, please let me know. I think I'll try to find some more, like, examples of different, more extreme face poses for the example files so that people can go and test it out. But yeah, this was good. Shape keys. Alright, I think that is everything. Thank you all for watching, and I will see you all next time. Have a good one.